H.3 M. Let's have a look at public exam questions. Question A. On a graph paper, draw the following straight lines. Here we have 3 straight lines, and below we have the rectangular coordinate plane. And this graph paper, we need to draw these 3 straight lines. Okay, easy. So let's have a look. Y equals 2x. Then set some points. This time, if you set x equals 0, then y equals 0. Then you need to think another 2 points. For example, x equals 10, y equals 20. Okay, and x equals 30, and then 60. Okay, let's see. X plus y equals 30. Then how about this one? X equals 0, then y equals 30. And if y equals 0, x equals 30. Yes. Then next, x equals 10, y equals 20. Okay. How about the last straight line? 2x plus 3y equals 120. When x equals 0, then y equals 40. When y equals 0, then x equals 60. In between, think about 1 point. Okay, x equals 30, y equals 20. That's great. Then we can make use of this order the pair the coordinates of each straight lines. So let's see. Here we need to mark the scales. So 10. Okay, maybe use the pencil. 10, 20, and then goes on. Then how about vertical axis, y-axis? Same as mark it as 10, 20, 30, and goes on. So y equals 2x, y equals 2x, then 0, 0, right, 10, 20, right, 30, 60, right. So as a result, you can mark it like this. Great. And this one, y equals 2x. Okay, how about next? X plus y equals 30. Not difficult. Mark these 2 points. Then draw a straight line here. Right. So this one, x plus y equals 30. How about the last one? 2x plus 3y equals 120. So 0, 40. 20, not 20, 30, 20. And one more, 60, 0. Right, so this one will become like this. Right. Okay, so this one, 2x plus 3y equals 120. Great, we have thus 3 straight lines. Part B. On the same graph paper, check the region that satisfies all the following inequalities. Okay, this one actually 1, 2, 3. According to the inequalities 1, 2, and 3. 3 straight lines we have been drawn in part A. So y equals 0 here. And greater than, that means the upper regions, not upper, sorry. It should be, let me see. Draw it now. y equals 0, upper part, upper half plane, right? And the other one, y smaller than, you see, y smaller than. So that means lower half plane. That means this part, right? How about x plus y greater than 30, greater or equals to 30? Again, this one, positive y greater than. So upper half plane. Upper half plane. Okay? How about the last one? Positive 3y smaller than something. So this one, lower half plane, right? Lower half plane. See? So after this 3 and including y greater than 0, then where is the shaded region? Yeah, great. This part, okay? Maybe I shake it properly. Okay, shake it like this. Okay, so this is the feasible regions. The region satisfy all the inequalities in part B. Right, great. Let's have a look at part C. Now it is given that P equals 3x plus 2y. This is the, remember, what's this? Yeah, objective function. Great, objective function. Under the constraint given by inequality in part B, find the maximum minimum values of P. So this one as the maximum minimum values of P. Part 2, again maximum minimum, but if there is an addition constraint, if there is an additional constraint, this one. Okay, do the part C1 first. Okay, so C1, P equals 3x plus 2y. Okay, by using method 1, then you need to draw a line first. 3x plus 2y equals 0, right? So for this one, if you rearrange it, let me use another color. So 3x equals negative 2y, then y over x equals 3 over negative 2, right? So you have a 2 points, negative 2, 3, and 2, negative 3, right? So mark it here. How about this? So let's draw the straight line. And remember, you need to draw, oh sorry, you need to draw this one. Okay, this one as P. P equals 3x plus 2y, right? So after that, goes on to draw and see which point is the first point touching the feasible regions. Okay, so this one, okay, is the first point touching the feasible regions, this point. Okay, enlarge it a little bit. Okay, then where is the last point? Do you know? Yeah, you found that about this point, right? So draw this line. Okay, so this one out. use the dotted line, no, solid line. This one is P this one, okay? 1 point, okay, this one is A, PA, the point A, okay, 3x plus 2y. This one is point A. This one is point C, okay? PC equals 3x plus 2y. And this one mark it as B, later we'll use it, and this one as D, okay? Pick up all the vertices in this shaded regions, and it can help us to find out the maximum and minimum. So after that, at A, you found that 10, 20, right? So is it maximum or minimum? Yeah, minimum. Good. Minimum of P equals 3 times 10 plus 2 times 20. So it equals 70. How about maximum of P equals, okay, here at point C, 60, 0. 3 times 60 plus 2 times 0. So you see that 180. Okay? Now if we use a method 2, think about it. P equals 3x plus 2y. And you need to check all the vertices. Remember? Method 2, you need to check all the vertices. At A, so 10, 20, B. What is the value of B? Yeah, you need to find the intersecting point of these two straight lines. That means 2x plus 3y equals 20 and y equals 2x. Okay? You need to solve these two straight lines equations if you're not really clear about the point. Actually, this one is 15, 30. Okay, how about C? 60, 0. How about D? 30, 0. Right. So P equals 3 times 10 plus 2 times 20. Right. So this one equals 70. B, 3 times 15. And then 2 times 30. So this one, 105. Point C, 3 times 60 and 2 times 0, 180. D, 3 times 30 and then 2 times 0 again, 90. So as a result, minimum of P is 70 and maximum of P is 180. Clear? So you can use method 1 or method 2, either one method, to find out the maximum and the minimum value. Okay? This time, no need to specify the point. Okay? Sometimes you need to write down which point you can obtain the maximum or minimum value. Okay, have a look past C. 2. Now this time we have another addition constraint. Is smaller than 45. So I use this color. 45, that means you need to draw this one. Maybe I use the red color. Oh, yeah, like this. Okay, x equals 45. Here, smaller than. So smaller than. Okay, now we have another 2 points. E and F. Point E and point F, right? So actually we can use method 2 to point out two more extra points, E and F. So let's see. I'll write down here C2. P equals 3x plus 2, 1. So at, you need to write down 10, 20, point A, B, 15, 30, no more C, this time is D, 30, 0. You need to compare all the points, 45, 10, and F, 45, 0. So what are the values of P? So calculate. So this one 70, 3 times 15, 3 times 2 times 30. So this one 105, or you can say that this one by C1. Okay. So 90. Another 2 you need to calculate. Great. At the end, you found that at E 4510 maximum of P equals 155. At A, still is A, minimum of P equals 70. Okay, so extra constraint, you get another 2 points, then you found that the maximum change becomes 155 and minimum no change, still 70. Understand? So have a look, this extra constraint, you get another point. So here 1, 2, 3, 4, 5, you need to check 5 points. Remember, use method 2, you must check all the vertices. If the vertices have 1 point at 0, 0, you still have to check it. Remember? Okay.